All right, let's dive into something really cool today, something a bit unusual. We're going to be talking about sonochemistry.
Sonochemistry.
And just to get us started, um, I think everybody's heard of putting on some music when you're cooking, just kind of get in the mood.
Right.
But imagine if you could use sound waves not just to set the mood, but to actually drive chemical reactions.
Wow, that's fascinating.
That's the idea behind sonochemistry, using sound waves to make those molecules really get moving.
Like a molecular dance party.
Yeah. Today, we're going to be digging into some incredible facts from Cocktail Party Chemistry. Their episode is called The Sound of Molecules, appropriately enough.
That sounds fun.
I think it's going to be pretty wild.
Yeah.
And I think it's going to change the way you think about sound and how it impacts the world around us.
I'm looking forward to it.
So I've got 5 key takeaways we'll be looking at today, and I think each one is even more mind-blowing than the last.
Okay.
First up, we're going to look at the concept of sonochemistry itself, how sound waves can make reactions happen.
Like, how does that even work?
Yeah.
Sound-making chemistry happen.
We'll get to that. And then we'll dig into cavitation, and that's where these tiny bubbles formed by sound waves implode with unbelievable force.
That sounds intense.
It is. And then, if tiny bubbles weren't enough, we'll also explore nanobubbles and how they can boost those reactions.
Nano. Even tinier.
Even tinier. Then we're going to talk about the green side of sonochemistry. We'll look at how we could actually use ultrasound to get rid of toxic solvents in some reactions.
So a more eco-friendly approach.
Exactly. And then, last but not least, we're talking extreme conditions.
Mm.
Get ready for this, because sonochemistry can create localized hotspots that reach a mind-boggling 5,000 Kelvin.
5,000 Kelvin.
Hotter than the surface of the sun, all from sound waves.
Wow.
It's wild, right? So get ready to crank up your knowledge, because we're about to unpack the world of sonochemistry.
I'm ready.
All right. So, we always think about heat or pressure when we're thinking about chemical reactions, maybe a catalyst.
Right, the things that make reactions go.
Yeah, but sonochemistry is kind of a game changer. It's like we're adding a whole new dimension to chemistry using sound waves.
What's fascinating is that we're using these sound waves to manipulate molecules at a really basic level.
Absolutely. And it's not just theoretical. It's
Yeah.
got real-world applications.
So how does it actually work? How did these sound waves, especially the ultrasonic kind, actually make these reactions happen?
Well, traditional chemistry, we're often using a lot of heat, right?
Yeah.
Or harsh chemicals to
Mhm.
get those molecules moving around and reacting.
Brute force.
Yeah, you could call it that. Sonochemistry is more like a delicate dance.
Okay.
We're using sound waves to kind of nudge those molecules into the right spots and give them a bit of energy to react.
Interesting. So it's more of a controlled, precise approach.
Exactly. And ultrasound is particularly good at creating these high-energy environments within a liquid.
And that's where those tiny bubbles come into play, right?
Exactly. We'll talk about those next, but they enhance the reactivity.
So we're using sound waves to kind of orchestrate this whole reaction.
That's a good way to put it. And the beauty of it is, it can actually lead to cleaner and more sustainable processes, which we'll talk about later too. But for now, let's talk about cavitation, because that's where things get really wild.
Okay, cavitation.
Those tiny bubbles we keep mentioning.
Yeah.
These bubbles are created by the ultrasound waves in a liquid.
Right.
And when they collapse, oh man, they implode with incredible force.
So cavitation is basically those ultrasound waves creating these tiny, tiny bubbles, and those bubbles implode.
Yeah, and it's not just a gentle pop. It's like a miniature explosion.
Wow.
And these implosions generate these incredible hotspots, tiny little areas with unbelievable temperatures and pressures.
So these hotspots, what kind of temperatures are we talking about?
5,000 Kelvin.
5,000 Kelvin.
Yeah, that's hotter than the surface of the sun.
I know we mentioned it before, but that's just crazy to think about, all from the collapse of these tiny little bubbles.
Right. It's mind-boggling when you think about the scale. We're talking about something smaller than the width of a human hair.
It's like each bubble is a tiny supernova.
Yeah, creating these extreme conditions, but only for a fleeting moment.
But even in those incredibly short bursts, they can drive reactions that just wouldn't be possible otherwise.
Exactly. That's what makes sonochemistry so unique. We're creating these extreme conditions that allow for reactions that just wouldn't happen under normal circumstances.
So it's opening up a whole new world of chemical possibilities.
It is, and we're just getting started.
Okay, so we've got sound waves creating these high-energy bubbles, but then we also have nanobubbles. What are those exactly? Are they just smaller versions of the cavitation bubbles?
Nanobubbles, those are really interesting. They're incredibly tiny, obviously, as the name suggests.
Yeah.
but they're surprisingly stable, and that's what makes them so valuable in sonochemistry. They can really boost the efficiency of these reactions. Well, think of them like little tiny reaction vessels. They concentrate the energy from the sound waves, and they also increase the surface area where reactions can take place.
I see. So more surface area means more opportunities for the molecules to interact and react.
Yeah, exactly. You know how a little bit of soap can create a ton of bubbles in your bath?
Of course.
It's kind of like that. Those nanobubbles, they're like multiplying the effects of those sound waves, making the whole process more efficient.
So each nanobubble is like a tiny little reactor working away thanks to the sound waves.
That's a great way to picture it. So we've got these powerful bubbles, we've got the nanobubbles, but sonochemistry also has a greener side, which I'm really excited to talk about.
Yeah, the eco-friendly aspect of it is really intriguing. How exactly does ultrasound help us replace those toxic solvents that are often used in chemistry?
Right. Well, think about it. In so many chemical reactions, we use solvents.
Yeah, they help things mix and react properly.
Right? They dissolve the stuff, they create the right environment for it to happen. But a lot of those solvents are, well, they're not great.
They can be pretty nasty.
Yeah, toxic, flammable, not good for the environment. And that's where ultrasound steps in. It can sometimes actually replace those solvents.
How does it do that?
Well, we've been talking about cavitation bubbles and those nanobubbles.
Mm-hmm.
They can actually create the right conditions for the reactions to go without needing all those harsh chemicals.
Wow, that's pretty amazing. So instead of using something toxic, we're just using sound waves.
Exactly. And that's a much more sustainable and eco-friendly way to do chemistry. It's really exciting. Now, are you ready for those extreme conditions?
Let's talk about those hot spots. 5,000 Kelvin. It's incredible. What kind of reactions are even possible under those conditions?
This is where it gets really, really interesting. Those hot spots, even though they only last for a tiny fraction of a second, they create an environment unlike anything we can create normally. We're talking about the kind of temperatures and pressures that can break down even the toughest molecules, make them rearrange in ways that wouldn't happen otherwise.
Wow. That's like opening up a whole new world of chemistry.
Exactly. We can create new materials, new compounds that we never even thought were possible.
So it's not just about making existing reactions more efficient, it's about making completely new things.
Exactly. It's like having a tiny glimpse into the extreme conditions that existed in the early universe, but right there in our little reaction flask.
And this is all thanks to sound waves.
Sound waves, that's right. It's amazing what we can do when we think outside the box and harness the power of things that we maybe take for granted, like sound.
I think that's a great point. So where does sonochemistry go from here? What's the future of this field?
Well, it's still a relatively young field, but it's growing fast. And as we understand more about how it works, we're finding more and more potential uses.
What are some of the most promising applications?
Oh, it's got a lot of potential in fields like medicine, material science, even environmental remediation.
That's incredible.
It really has the potential to revolutionize the way we approach chemical synthesis, making it cleaner, more efficient, and way more sustainable. And who knows what other discoveries are waiting for us as we delve deeper into those extreme conditions that sonochemistry can create.
That's a good point. It makes you think, if we can harness the power of sound waves to do all this, what other unseen forces could we use to create new innovations? What about light, magnetism, or even gravity?
That's a really intriguing question.
It really makes you think about the possibilities and the power of exploring those seemingly invisible forces.
It does, and it shows that there's so much more out there to learn, to discover, and to apply to the challenges we face in the world.
So we've explored how sound can drive reactions, but what about a material that seems to defy gravity? Have you ever heard of pyrolytic carbon?
Pyrolytic carbon. It sounds familiar, but refresh my memory.
Well, it's a material that can actually levitate above magnets.
Levitate. Really? I'd love to see that.
It's pretty mind-blowing, and it all comes down to this property called diamagnetism.
Diamagnetism. Tell me more.
Okay, so diamagnetism is basically a material's tendency to be repelled by a magnetic field.
Okay, so it's like the opposite of being attracted to a magnet.
Exactly. And most materials are diamagnetic to some degree, but it's usually so weak we don't even notice it. But pyrolytic carbon, it's exceptionally diamagnetic. It's repelled by magnets with so much force, it can actually overcome gravity and just float.
So it's not actually defying gravity. It's
Yeah.
being pushed away by the magnetic field so strongly that it appears to levitate.
That's exactly it. It's like an invisible force field is holding it up.
That's still pretty amazing. So what makes pyrolytic carbon so special? Why is it so much more diamagnetic than other materials?
It's all about its structure. Pyrolytic carbon is made by heating up hydrocarbons to super high temperatures in a vacuum. And this creates a very ordered, layered structure, almost like a perfectly stacked deck of cards, but on a molecular level. And it's this highly organized structure that makes it so incredibly diamagnetic.
So it's basically a super organized version of carbon that's really good at repelling magnets.
You got it.
That's pretty cool. So besides just being fun to watch, does this levitating carbon have any practical applications?
Absolutely. It's got some really cool uses, especially in medicine and aerospace.
Okay, give me an example. I'm trying to imagine how levitating carbon would be useful in those fields.
Well, take artificial heart valves, for example. Pyrolytic carbon is incredibly biocompatible, meaning it doesn't trigger any negative reactions in the body, so it's often used to make heart valves that can function for years without being rejected by the body.
That makes sense. What about the aerospace applications?
Pyrolytic carbon is also super strong and heat resistant, which is perfect for extreme environments. So it's used in things like rocket nozzles, where it can withstand the crazy temperatures and pressures during launch. It's also used in high-performance brakes and even in some types of nuclear reactors.
Wow, that's quite a range.
Yeah,
So this levitating carbon is much more than just a cool science trick.
definitely. It's a perfect example of how exploring the fundamental properties of materials can lead to some amazing and totally unexpected innovations. It really makes you wonder what other surprising materials are out there just waiting to be discovered.
That's the beauty of science, right? There's always something new to uncover. And often the most unexpected discoveries lead to the most incredible technologies.
Speaking of unexpected discoveries and technologies, there's been some amazing research recently on this material called nitinol.
Nitinol.
It's a shape memory alloy.
Shape memory alloy. You mean it can remember its original shape?
Exactly. It might sound like something straight out of science fiction, but it's real. And it's all because of how the atoms are arranged within the material.
Okay, I'm intrigued. Tell me more about this shape-shifting metal.
Nitinol is a special alloy of nickel and titanium, and it has this incredible ability to change its structure when it's heated up.
Okay.
We call that a phase transformation.
Phase transformation.
Yeah, the atoms in the metal rearrange themselves into a different crystal structure. It's kind of like a group of dancers shifting from a waltz to a tango.
Mhm.
Same dancers, but they change how they're arranged, which changes the whole feel.
That's a great analogy. So how does that translate to shape memory?
The cool thing is that this change in structure is reversible. So
Mhm.
you can bend and twist nitinol all you want, and then when you heat it up, it'll just spring right back to its original shape.
It's like a metal that can heal itself.
Exactly. And this property makes it incredibly useful, especially in medicine and engineering.
I can imagine that. What kind of applications are we talking about?
One of the biggest ones is stents. Those are the tiny tubes used to open up blocked arteries.
Oh, right.
So the stent is inserted in its compact form, and then when it warms up to body temperature, it expands to its preset shape, holding that artery open.
Wow, that's amazing. It's like a tiny little robot working inside your body.
Exactly. And because nitinol is biocompatible, it's perfect for medical implants.
Right, right.
It's also being used in things like eyeglass frames that can bend and then spring back, dental braces, and even robotic actuators.
So it's a versatile material with tons of potential.
It really is. Are there any downsides or limitations to using it, though?
One of the main challenges is fatigue. If you bend and unbend nitinol too many times, it can lose its shape memory. Makes sense.
But researchers are working on making it more durable, so it's a really promising material for the future.
It's amazing to think about. A material that can change its shape on demand. It opens up so many possibilities for new technologies.
Absolutely. And it's just another example of how material science is pushing boundaries and changing what's possible.
Okay, I'm ready for another mind-bending material. What else have you got for us?
Have you ever heard of cold welding?
Cold welding. I thought welding always needed heat.
That's what's so fascinating about it. Cold welding lets you bond metals together without any heat or pressure.
Wait, are you telling me you can just stick two pieces of metal together and they'll fuse? How does that even work?
It sounds impossible, but it all comes down to how atoms behave at the surface of metals.
Okay.
If you have two super clean and smooth metal surfaces and they touch in a vacuum, their atoms can actually bond directly to each other.
So it's like they're so close together that they just become one.
Exactly. It's as if those two pieces were never separate. And because there's no air or anything to get in the way, the bond can be incredibly strong.
That's amazing. So this works in a vacuum, but can we use it in the real world?
It's not as common as regular welding, but cold welding does have some specialized application.
Like what? Give me some examples.
Well, it's used in aerospace sometimes to join parts that are sensitive to heat, and also in microelectronics where they need to connect tiny wires really precisely.
Makes sense. But why isn't it used more widely if it's so useful?
The big challenge is getting those perfectly clean, smooth surfaces. Even a little bit of contamination can mess up the bonding.
Right, I can see how that would be tough.
So for now, it's mostly used in very specific situations. But as nanotechnology gets better, cold welding might become more common.
It's fascinating to think about. Joining things without heat or pressure, especially as we keep making smaller and smaller electronics.
It is. It reminds us that even in something as basic as joining two pieces of metal, there's a whole world of chemistry going on. And sometimes that chemistry can lead to some really amazing visual effects, too. Have you ever seen those Lichtenberg figures?
Lichtenberg figures? I'm not sure I've heard of those. What are they?
They're those intricate branching patterns you see created by lightning strikes.
Oh, right. I've seen pictures of those. They look like works of art, but they're created by something as destructive as lightning.
It's a beautiful example of how even chaos can create these stunning patterns. But have you ever wondered how they form?
I have. It's always looked so random to me,
Yeah.
but clearly there's some science behind it.
It's all about how electricity moves through different materials. When lightning strikes, it's a massive surge of electrical energy.
Okay.
And as that energy flows through something like skin or wood, it can cause tiny little pathways of damage.
So the electricity is basically carving its path through the material.
Exactly. And the shape of that path depends on how easily the electricity can flow through the material. So it's like a map of the lightning's journey through that material.
That's so cool. Are Lichtenberg figures only found on skin, though?
No, they can be found on all sorts of things, like wood, acrylic, even inside electronics that have been damaged by electrical surges.
Wow.
It's as if the electricity is trying to find the most efficient path. And in doing so, it creates this beautiful branching design. And what makes those designs so captivating is their fractal nature.
Fractal.
Yeah, each little branch echoes the shape of the bigger pattern. It's a kind of infinite complexity within a limited space.
That's a really cool way to think about it. It's incredible how something as brief as a lightning strike can leave behind such intricate and long-lasting patterns.
It is. It shows us that even in the most powerful forces of nature, there's a hidden beauty and order to be found.
Absolutely.
And speaking of powerful forces and order, have you ever heard of nuclear pasta?
Nuclear pasta. That sounds like something you'd order at a very strange restaurant.
It does, doesn't it? But it's a real thing, though you won't find it on any menu here on Earth. Nuclear pasta exists deep inside neutron stars.
Okay, now you have to explain this. What is nuclear pasta and how does it form?
Imagine a material so dense that a teaspoonful would weigh billions of tons. That's nuclear pasta. It forms under the immense gravity found in neutron stars, where protons and neutrons are squeezed together incredibly tightly, and they actually form these pasta-like shapes.
Wait a minute, you're saying inside these incredibly dense stars, the fundamental building blocks of matter are squished together to form, like spaghetti and lasagna.
It might sound strange, but that's essentially what's happening. The intense pressure forces those protons and neutrons to arrange themselves into elongated structures. And scientists have given them playful names like nuclear spaghetti, nuclear lasagna, even nuclear gnocchi, based on their shapes.
This is mind-blowing.
It is pretty wild.
Why do they form these specific shapes, though? What's causing this cosmic pasta-making process?
It all comes down to the balance between the nuclear forces holding those particles together and the extreme gravitational pressure within the neutron star. And these forces create an energy landscape that favors certain configurations, leading to those bizarre pasta-like shapes.
So it's like a giant cosmic game of Tetris, where the pieces are protons and neutrons.
Exactly, and the result is this material that's not only super dense, but also thought to be the strongest known material in the entire universe.
Wow. So what's the point of nuclear pasta? What does it actually do?
Well, we can't directly observe it, but it's believed to affect how neutron stars behave, like how they cool down, how they emit radiation, and it might even play a role in those glitches and starquakes we observe.
So it's like the hidden scaffolding inside these stars shaping how they act.
Exactly. And it shows us the incredible diversity of materials in the universe and the mind-blowing conditions that can create them.
It really makes you appreciate how much we still don't know about the universe.
Absolutely. It's a constant reminder to keep exploring.
Speaking of exploring, sometimes those extreme conditions and the forces that shape matter, they play out in ways that affect our everyday lives, like with smog.
Smog.
Yeah, it's a reminder of how human activity can really mess with the chemistry of our atmosphere.
It's a constant challenge in so many cities around the world. What exactly is smog and how does it form?
Well, smog is this hazy mix of pollutants that hangs in the air.
Right.
It's mostly caused by a bunch of chemical reactions happening between things like nitrogen oxides, volatile organic compounds, and sunlight.
So it's not just one thing, it's a combination of chemicals reacting together.
Yeah, it's a cocktail of bad stuff.
Okay.
And the nitrogen oxides come from car exhaust and industrial emissions, and the volatile organic compounds come from things like gasoline, paints, and solvents. And when those things get hit with sunlight, they react, producing ozone, particulate matter, and a bunch of other nasty pollutants.
And that's what we see is that hazy blanket over cities.
Exactly. It not only looks bad, but it's also terrible for our health.
Right.
It can cause respiratory problems, heart problems, even increase the risk of cancer. It's pretty scary to think that something as simple as driving a car can contribute to all of that.
You're right. It's a reminder that we need to understand the chemistry behind these problems.
Yeah, if we want to find solutions to reduce emissions and make the air cleaner and healthier,
It's a complex issue that needs collaborative efforts from scientists, policymakers, and individuals to address it.
definitely. It's a reminder that chemistry is all around us, and understanding it is crucial for tackling some of the biggest challenges facing our planet.
And speaking of challenges, there's this interesting phenomenon, kind of a social one, related to our perception of chemicals. Chemophobia.
Chromophobia.
Yeah, the fear of chemicals. It's when people are afraid of anything labeled as chemical, even though everything around us, including our own bodies, is made of chemicals.
Right.
It's a fascinating example of how public perception can clash with scientific reality.
That's true. It seems like the word chemical has taken on a negative connotation.
It has. But in reality, chemicals are just the building blocks of everything. They can be good or bad depending on how they're used.
So it's not the chemicals themselves that are the problem. It's about understanding their properties and using them responsibly.
Exactly. And that's where education is so important. We need to help people understand the basics of chemistry and toxicology so they can make informed decisions and separate fact from fiction.
It's about recognizing that everything is a chemical and remembering the saying, the dose makes the poison.
Right. A tiny bit of something might be harmless while a large amount could be dangerous. And lots of natural substances can be toxic too. It's all about the details.
It's a good reminder that things aren't always as simple as they seem.
Definitely. Chemophobia is a complex issue, but it shows how important clear communication and scientific literacy are, especially when it comes to understanding the role of chemistry in our lives.
Absolutely. And speaking of the role of chemistry in our lives, I think music is a fantastic example of how chemistry can affect us emotionally and even physically.
Music. I love that connection. I hadn't really thought about it in that way before.
It's amazing when you think about it. Music is often called the universal language, and it really does have a profound impact on us. Have you ever thought about the science behind that?
I've definitely experienced the power of music, but I haven't dug into the scientific details.
Well, research has shown that listening to music triggers all sorts of reactions in our brains. It releases hormones like dopamine and endorphins, which are linked to pleasure and reward.
So that's why music can make us feel so good.
Yeah, it's like a chemical party in your brain. And different types of music can evoke different emotions: joy, excitement, sadness, even fear.
It really shows the power of music to tap into our emotions.
Absolutely. And music isn't just about entertainment. It can also be therapeutic, helping to reduce stress, relieve pain, and even improve cognitive function in some cases.
That's fascinating. It's like we can harness the power of music to improve our well-being.
It's a great example of how powerful chemistry can be, and it works in ways we don't even realize. It really is all around us, even in the most unexpected places.
You're absolutely right. And sometimes those unexpected places can lead us to explore some pretty interesting and even controversial topics, like the resurgence of psychedelics in medicine.
Psychedelics. That's a topic that's been getting a lot of attention recently.
It has. These substances have been surrounded by stigma and misconceptions for so long.
Yeah.
But new research is shedding light on their potential therapeutic benefit.
I've heard about the potential for treating conditions like depression and anxiety, but I have to admit, I'm still a bit cautious about it.
I understand. They're powerful substances, and they need to be treated with caution and respect. But controlled studies are showing that compounds like psilocybin, which is found in magic mushrooms, and LSD can actually have remarkable effects when used in therapy.
Really? How do they work? What's the science behind these therapeutic benefits?
Well, it's believed that psychedelics work by temporarily changing certain neural pathways in the brain,
Okay.
especially the default mode network, which is involved in our sense of self and ego. And this disruption can loosen up rigid thought patterns and create a feeling of expanded consciousness.
So it's like hitting a reset button on the brain, helping people break free from negative thought patterns.
Exactly, and that can be incredibly helpful for people struggling with mental health issues.
It's fascinating that these substances that were once demonized are now being investigated for their potential to heal.
It really shows how science is always evolving and how important it is to stay open to new possibilities, even if they challenge our preconceived notions.
Well said. The resurgence of psychedelics in medicine is a powerful reminder that there's always more to learn and discover. And sometimes the most unexpected sources can lead to incredible breakthroughs.
And speaking of unexpected sources and breakthroughs, we often overlook the beauty and complexity of natural dyes.
Natural dyes.
They're a great example of how chemistry can be both aesthetically pleasing and good for the environment.
I've always loved the rich colors of natural dyes. They seem to have a depth and vibrancy that's hard to find in synthetic colors.
They really do, and it all comes down to the unique structures of the molecules found in plants, insects, and even minerals. These molecules interact with light in special ways, creating the colors we see.
So each natural dye has its own unique way of absorbing and reflecting light.
Exactly. And what's really cool is that the color of a natural dye can change depending on things like the soil, the time of year it was harvested, and even the techniques used to dye the fabric.
That's amazing.
It really adds to the artistry of working with natural dyes. And it reminds us that chemistry isn't just about equations and labs. It's about the beauty and wonder that exists all around us.
Well said. It's a great reminder that nature is full of these amazing chemical compounds that can create a whole spectrum of colors.
And speaking of color, have you ever noticed how food tastes better when it's beautifully presented?
Oh, absolutely. I'm a big believer in the power of presentation.
There's a fascinating connection between what we see and what we taste.
Tell me more about that.
Well, research has shown that our brains actually start processing visual cues about food before we even take a bite.
Okay.
And those visual cues can set expectations that affect how we perceive the taste and flavor.
So our eyes are kind of priming our taste buds.
Exactly. And it can make a big difference. A beautifully plated dish with appealing colors, textures, and even aromas can actually make the food taste better.
That's incredible. So it's not just about the quality of the ingredients, it's also about the presentation.
Absolutely. There's a real art to eating with our eyes. It shows how our senses work together to create a more enjoyable experience.
It makes you appreciate the skill of chefs who can create not just delicious food, but also visually stunning dishes.
Exactly. It's where science and art meet in a really delicious way.
Speaking of science and art, and maybe a slightly less appetizing topic, there's this interesting thing the FDA does with food production. Have you ever heard of the FDA's Defect Levels Handbook?
The Defects Levels Handbook, that doesn't sound too appealing.
It doesn't, but it offers a glimpse into the reality of how our food is made and the fine line between safety and practicality.
Okay, I'm curious, but tell me more about it.
Okay, so the FDA knows that it's pretty much impossible to have perfectly pure food, especially processed stuff like grains or spices or chocolate. So they actually have these set levels for things that are allowed in our food, like bug parts, rodent hairs, even mold.
Wait, hold on. You're telling me there are bugs and rodent parts in my food, and the FDA is okay with that?
Well, it's not quite as gross as it sounds. These are called defect levels, and they're based on a ton of scientific research. They set those levels to make sure that the food is still safe to eat.
So they're saying a tiny amount of those things won't hurt us.
Yeah, it's all about managing risk and understanding how food is made these days. It's impossible to get rid of every tiny speck of everything.
I guess it's a reality check about our food system.
It is. It's a compromise between keeping things safe and keeping things practical. The FDA makes sure it's all within acceptable limits, though.
That's good to know. It's reassuring to know that someone is keeping an eye on these things.
Absolutely. The FDA has a huge job in making sure our food is safe. But, our own bodies are amazing systems, too, always adapting and changing based on what we experience. Have you ever heard of neuroplasticity?
Neuroplasticity, yeah. I've heard the saying, neurons that fire together wire together. But I'm not totally clear on what it means.
That's a great way to sum it up. Every time we learn something new, have a new experience, even just think a thought, our brains create new connections between our neurons.
Wow.
And that strengthens the pathways in our brains.
So our brains are constantly rewiring themselves.
That's right. And this can happen throughout our lives, from childhood to old age.
So we're not stuck with the brain we're born with.
Nope. We can actually change our brains by what we do and how we think.
So that means that learning new skills or having new experiences can actually change the physical structure of our brains.
Exactly. And it allows our brains to adapt to new situations. Like people who have had a stroke can often regain some abilities because their brains rewire themselves through therapy.
That's incredible. It's a testament to how amazing the human brain is.
It really is. It's a
Yeah.
powerful reminder to keep our minds active and engaged.
Absolutely. And when we delve deeper into the brain, there are certain regions that play key roles in our emotions and memories, even our instincts for survival, like the amygdala. Never heard of it.
The amygdala. I think this is often called the fear center of the brain, right?
It is, but its role is actually much more complex than that. The amygdala is this small almond-shaped structure deep in the brain, and it acts as a kind of central hub for processing emotions, especially those related to fear and threats.
So it's like our brain's alarm system.
Yeah, you could say that. It's constantly taking in sensory information from our surroundings and figuring out if there's danger.
Okay.
And if it senses danger, it triggers all those physical responses we get when we're afraid, like a faster heart rate, quicker breathing, and the release of stress hormones, which prepare us to fight or run away.
That makes a lot of sense.
Uh,
But the amygdala doesn't just deal with fear, right?
mhm.
What about other emotions?
That's a great question. It's also involved in processing positive emotions like happiness and excitement.
Mm.
And it plays a crucial role in how we form memories, particularly emotional memories. That's why certain smells, sounds, or places can bring back such strong feelings.
So it's like a library of emotional experiences that helps us understand and react to the world around us.
Exactly. That ability to create emotional memories helps us assess situations quickly and decide how to respond, whether it's getting out of danger or seeking out something enjoyable.
It's amazing to think about this little part of our brains having such a big influence on our emotions and how we behave.
It's a powerful reminder of how complex and interconnected our brains are.
Absolutely. And, sometimes those connections even extend beyond our own bodies, influencing our interactions with others.
Oh, interesting. Like how...
Think about how calming the scent of a newborn baby is. Have you ever noticed that?
Oh, definitely. There's just something so soothing about that new baby smell.
It's not just our perception either. There's actually some cool chemistry behind that effect.
Really? I thought it was just the cuteness.
Well, cuteness definitely helps. But research has shown that babies actually release a chemical called hexadecanal. And it's been found to have a calming and relaxing effect on adults.
Hold on. Babies are emitting chemicals that make us feel good. That sounds like something out of a sci-fi movie.
It does, doesn't it? But it's an amazing example of how chemical signals can shape our social interactions. It's believed to be part of how humans evolved to form those strong bonds between parents and their children.
So it's like a built-in mechanism to make sure we take care of our babies.
Exactly. It's a clever strategy that evolution came up with.
Yeah.
And it shows how much chemical communication is going on beneath the surface, even in our most basic relationships.
It makes you wonder what other subtle chemical signals we're sending and receiving all the time without realizing it.
That's a great question. It's a whole field of research that scientists are still trying to understand.
I bet there are a lot of surprises waiting to be discovered.
I'm sure there are. But for now, let's get back to something a bit more, well, down to earth. Remember that FDA handbook we talked about?
The one with the bug parts and stuff.
Yeah, that one. Well, the FDA also regulates another thing that might make some people a little uneasy. The amount of filth allowed in our food.
Wait, filth? What do you mean?
Well, like we were saying before, it's almost impossible to have perfectly clean food. So the FDA sets limits for things like insect fragments, rodent hairs, mold, that kind of stuff.
So it's kind of like a necessary evil.
I guess you could say that. They're trying to find a balance between keeping food safe and acknowledging that a tiny amount of those things is probably inevitable in our food system.
It makes sense, but it's still a little unsettling to think about.
I know what you mean. It definitely gives you a new perspective on what's going on behind the scenes in the food industry.
It does. But on a more positive note, there have been some amazing breakthroughs in neuroscience that are giving us incredible insights into the brain.
Oh, yeah. Tell me more about those.
Have you ever heard of DREAD?
DREADDs. That sounds a little scary.
The name is a bit ominous, but it stands for Designer Receptors Exclusively Activated by Designer Drugs.
Okay, that's a mouthful. What are they and what makes them so special?
Imagine being able to turn specific brain cells on or off, just like flipping a switch. That's what DREADDs allow us to do.
Wait, are you saying we can control brain cells remotely? How does that work?
It's this ingenious combination of genetic engineering and chemistry. Scientists insert these specially designed receptors, called DREADs, into certain brain cells.
Okay.
And these receptors are made to respond only to a particular synthetic drug that doesn't affect any other cells in the body.
So it's like giving those brain cells a secret code that only we know.
Exactly. And by giving the drug, we can either activate or inhibit those cells depending on the type of dread.
Wow, that's incredible. What can we actually do with this technology?
It's opening up so many possibilities. Scientists can use DREADs to study specific brain circuits that are involved in all sorts of things, from how we move and feel to how we learn and remember. And by changing those circuits, we can learn even more about how the brain works and develop new treatments for brain disorders.
That's groundbreaking stuff. It sounds like dreads are giving us a whole new way to explore the brain.
They really are. It's just one example of how human ingenuity is helping us understand the complexity of the brain in ways we never thought possible. It's amazing to think we can target specific brain circuits with this level of precision.
It really does open up a whole new world for understanding the brain and maybe even treating neurological disorders better.
Absolutely. And it just shows how far we've come in trying to unlock the mysteries of the brain. But even with all these advancements, we're still just scratching the surface.
Yeah, there's still so much we don't know about the brain.
It's a constant journey of discovery, and that's what makes it so fascinating.
It really does. And as we keep learning more, I think it's important to remember that there are so many different ways of knowing and understanding.
Different ways of knowing.
Yeah, science is an incredible tool for understanding the physical world, but it's not the only way we make sense of things.
What other ways are there?
Well, there are things like indigenous knowledge systems, traditional healing practices, even artistic expression. They all offer unique insights and perspectives that can really enrich our understanding.
That's a good point. I think sometimes we get so focused on scientific progress that we forget about these other valuable forms of knowledge that have been around for centuries.
Exactly. And often these different ways of knowing can actually work together with science. Like indigenous cultures have this incredible understanding of the natural world that can inform our efforts in conservation and sustainability.
And traditional healing practices often take a more holistic approach, considering not just the physical, but also the emotional and spiritual well-being of a person.
That's right. It's all about recognizing that there are many paths to knowledge, and that embracing these different perspectives can lead to a much richer understanding of the world.
Well said. It's a good reminder that we can all learn from each other and that the search for knowledge should be a collaborative and inclusive effort.
Absolutely. Well, I think it's time for us to wrap up this deep dive into the amazing world of chemistry. It's been quite a journey, hasn't it?
It really has. We've covered so much, from those powerful sound waves to the intricate workings of the brain, from those vibrant natural dyes to those surprising FDA regulations.
It's been a whirlwind tour of the fascinating and sometimes unexpected impact that chemistry has on every aspect of our lives.
Chemistry really is everywhere, from the air we breathe to the food we eat to the thoughts that shape our perceptions of the world.
And the best part is that it's always changing, always revealing new discoveries and possibilities that challenge our understanding of the world around us and ourselves.
It makes you realize how much there is to learn and explore, and that the journey of discovery never really ends.
Well said. A huge thank you to you, our amazing expert, for sharing your knowledge and guiding us through this incredible deep dive.
It was my pleasure. I always love sharing my passion for chemistry, and I hope we've inspired our listeners to appreciate the wonders of this incredible field.
And to our wonderful listeners, thank you for joining us on this journey of exploration. We hope you've learned something new, challenged your perspectives, and maybe even sparked a newfound curiosity about the world around you.
Keep questioning, keep exploring, and keep diving deep into the endless possibilities of knowledge.
Until next time, stay curious, stay engaged, and remember, the world is a fascinating place, and chemistry is the key to unlocking its secrets.